In this video, I'm going to go over one of the questions on the homework that I had. So for problem number 38, we have a golf ball hit from a 4-story platform at TopGolf, and it's 30 meters above the ground. Okay, and we have an initial velocity. So here's our platform, here's the ground. So the golf ball is being hit from here, and its initial position, y naught, is 30 meters. If we set our reference frame where our 0 position is right here, our positive y direction is that way, and our positive x direction is that way, then our initial x direction or x position here, x naught, is going to be 0 meters for this golf ball. Okay, the golf ball is hit. We know that it is hit with an initial velocity of 65 meters per second. Okay, so we know that this is 65 meters per second. And we know it's at an angle of 60 degrees above the horizontal. Didn't draw that very well as a 60-degree angle, but we do know that this is 60 degrees. And we are asked first to calculate the x and y components of the initial velocity. Okay, so we have a 65 meter per second vector, and this angle is 60 degrees above the horizontal. So we can split this vector into its x component. And let's see if I can make that a little bit more horizontal. So this is our v naught x. Okay, and its initial y component, I might zoom in here a little bit. And our initial y component, b naught y. And we know this angle here is 60 degrees. So since v naught y is opposite of the angle, we know that the sine of 60 equals v naught y over 65. So we get an initial velocity in the y direction of 65 sine 60. Okay. And if we were to actually find the decimal answer for that, that ends up being 56.29 or 56.3 meters per second in our positive y direction. Okay, and if we were to look at our v naught x here, our v naught x is adjacent to the angle. So we know the cosine of 60 degrees equals v naught x divided by 65. And we multiply both sides by 65 to get v naught, our initial x velocity, equal to 65 cosine of 60. And a decimal number for that, we got 32.5, right? Because the cosine of 60 is just 1/2. 32.5 meters per second. Okay, then we're supposed to express the x and y components of the displacement as a function of time. Okay, so here we want to think about our big four kinematic equations that we know. So let's think about that. We have an equation, either I'll write it generally and not have the x or y subscripts. We know that we can apply it to either the x direction or the y direction. We have an equation that says v equals v naught plus at. We have an equation for constant acceleration linear motion of, here in this case, I'll do this one for the y direction. So in the x direction, we know if it's projectile motion, we know acceleration in the x equals 0 meters per second. We know that the acceleration in the y is going to be negative 9.80 meters per second squared, because the projectile is just under the influence of gravity. So we have an equation that says y equals y naught plus v naught yt plus 1/2 gt squared. And we have an equation, I'm listing out all the big four equations right now. We have another equation that says v squared equals v naught squared plus 2a. Actually, let's do this again for g. For the y direction, 2g y minus y naught. Okay, so, and we have a fourth one, but we don't use that fourth one very often. So let's just stick with those three for right now. So which one of these would give us the displacement as a function of time? Well, our equation here gives us displacement as a function of time. In the y direction, I have that one written, but let's plug in kind of the values that we know. So if we were to make a list of our variables in the x direction, we know x naught is 0. X, that's what we're gonna find an equation for x as a function of time. V naught x, we actually do know. It's 65 cosine 60. Our v x, we actually also know. Check this out. We don't have any acceleration, so we know that for the whole time that this object is in the air, its velocity in the x direction is going to be 65 cosine 60. Acceleration in the x equals 0. And the time, we're not given really any information about the time. Okay, and how about our inventory of variables for the y direction? So in the y direction here, we have y naught equals 30. Y equals, well, right now we're going to try to find an equation for y as a function of time. We know v naught y is 65 sine of 60 this time. And I'm running out of space here. Let's go 65 sine of 60. Vy, we don't really know. We know it's going to change over time. We know ay equals negative g in this case, negative 9.8 meters per second squared. And then our time, we aren't really given any information about time. Okay, so express the x and y components of the displacement as a function of time. So like I said, this is our equation we're going to want to use. This is our position as a function of time equation. For the x direction, if we were to write this out, x equals x naught plus v naught xt plus 1/2 ax t squared. Well, t is just 0, so this, a is just 0, so that whole term cancels out to 0. So what we end up with is an equation that says x equals x naught, which is 0, plus v naught x, which is 65 cosine of 60, times t. Okay, and we actually don't even need to write the 0, so we just get an equation that says x equals 65 cosine 60 times t. Okay, in the y direction though, we have kind of we have an acceleration, we know our initial velocity, we know our initial position, so we have y equals, well, y naught is going to be 30 meters, plus our v naught y times t. Well, our v naught y was 65 sine of 60 times t, plus, well, 1/2 g. Well, our g is negative 9.8, so negative, let's say negative 4.9. Well, actually, let's write it all. Negative 1/2 times 9.8. I switched the positive to a negative sign because our 9.8 was negative. And then we have a t squared. So that's going to be our equation for the y displacement as a function of time. Alrighty, so moving on to part C, calculate the time the golf ball is in the air. Okay, so here we have to think about, is it our x direction that dictates how long the ball is in the air, or is it our our y direction. Okay, well, our y direction is where the ball is actually falling towards the ground. Yes, if the ball has a greater initial x velocity, it may travel further for a given initial y velocity, but it's the y velocity, the initial y velocity, that dictates how long the object is going to be in the air. You can actually kind of treat it exactly like a free fall problem and just look at the y component to figure out how long it's in the air, because you have a certain amount of time with the given acceleration and the initial velocity that the ball will be able to stay in the air before it hits the ground. Okay, so we are going to want to look at our y direction equation for position as a function of time to figure this out. And when the time that the golf ball falls out of the air or is no longer in the air is going to be when our y position equals 0 meters, right? That's when it comes down here and hits the ground. So let's go ahead and plug in for y. So we're using this equation here. I'm going to plug in for y. 0 equals 30 plus, 65 sine of 60. I'm going to keep a sig fig, an additional sig fig. Was that 56.29 t minus 4.9 t squared. Okay, and then if I rearrange this, I can use the quadratic equation. So I have 0 equals negative 4.9 t squared plus 5.6 or 56.29 t plus 30. Okay, my quadratic formula or quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. So my b value is this 56, so negative 56.29 plus or minus the square root b squared 56.29 squared minus, oops, that's a 4. That's a terrible 4. Minus 4 times negative 4.9 times 30 all over 2 times a, which is negative 4.9. Okay, and when we solve that out, our answer that makes sense is going to be, so this is solving for time. So we are going to get 12.0 seconds as our answer here. Let me plug that into our calculator. And alrighty, folks, so now that takes us to part B, or to part D, calculate the horizontal distance traveled by the golf ball. Well, now we do know that the time, if the time that it took was 12 seconds, well, we know from doing our math that after 12 seconds, the ball is going to hit the ground. So we can then use our position as a function of time in the x using the time of 12 to figure out how far horizontally the ball traveled. So we have our equation from here. X equals x naught, which was 0. We said time plus 65 cosine 60 of t. Well, 65 cosine of 60 is just equal to 32.5. So we have 32.5 times 12 equals 390 meters, I believe. Yeah, because it's on your calculator 389.9, so that would round to 390. And if we're being really particular here, that 0 is significant, so we could also report this as 3.9. Oh, what is going on with my pen? 3.9 times 10 to the 2. 3.90, right, if we want to report 3 sig figs times 10 to the 2. Well, I'm glad the video is almost over because my pen is acting super weird. So the rest of the problem, there are actually a couple more parts to this problem, and really it just takes you through solving this problem in a different way so that you do not have to use the quadratic formula if you don't want to. So you could alternatively calculate the time it takes for the golf ball to reach the highest position in its flight. Well, we know that the highest position in its flight, we know that the Vy, oh boy, Vy equals 0 meters per second at that point in time. Okay, and then you can figure out using the time that you find at the top, you can calculate that maximum position y, and then the time it takes for the golf ball to fall to the surface from its maximum height, well, is going to be the same amount of time it took it to get to the, well, no, then you do like a free fall problem because it's hit from 30 meters up. So that time from the top down to when it hits the ground is going to be longer. But you can treat that sort of like a free fall problem. You know that highest height, you know that it's going to 0, and just figure out how long it takes for the ball to get to the ground using our y direction again. And then you can calculate the total time of the flight using your answers from E and G. Okay, so the time that you get for E should be 5, and if I can, hopefully I can write these down with my pen sort of working, 5.74 seconds. And in G, you should get 6.25 seconds. Okay, and the max height is going to be 192 meters. So let's see, 192 meters. Again, hopefully you can sort of read this. Yeah, and then so the total time, you just add the two together from E and G, and you get 12 again. 12.0 seconds if you carry out all the decimal places. Okay, hopefully this was helpful. This is kind of a good problem to kind of summarize or challenge you to understand projectile motion. We have an object leaving a surface and hitting a surface at a different height, so hitting a surface 30 meters below where it initially was projected. We know the magnitude and direction of that initial velocity vector, so we have to solve for components. And then use our understanding of projectile motion and how you have to analyze the x and y direction separately to figure out the time the ball is in the air and the distance traveled. Okay, and this problem steps you through 2 different ways that you can do that. Okay, hopefully this was helpful.